Isometric projection is a staple of classic gaming, seen in Diablo, SimCity 2000, and even more modern indie games like Project Zomboid, which all use layered 2D sprites to sell their pseudo 3D effect. I want to create an isometric engine in Python, but instead of layering sprites, I'll be using raycasting. To begin, we need some way of projecting 3D coordinates into 2D isometric ones. This formula here can be modified into a simple 2:1 ratio, and an offset for the center of the screen can be added, giving us this final formula. Now some people might try to tell you that this isn't technically isometric projection, as isometric projection requires 120-degree angles between all the axes. My response to these people is to humbly suggest they seek full-time employment. Using a sine function as a placeholder, we get this red blob. By adding chained if statements, we can create a simple color map, which slightly improves how it looks, but it's still not what I'm going for. Fortunately for me, Python's matplotlib library comes with a color map that can be easily applied over an array, and it makes it look a lot better. The one thing I really want to add is shadows. The way I implemented them was actually pretty simple. For every point in the height map, we check all points ahead of it in the array, and check if that point's height is greater than the distance between the 2 points. If true, we can divide that column's color by 3, creating a pretty accurate shadow. The limitations of this is you can't change the direction of the shadows, nor the angle that the light source is at. Now this has started to put some strain on my CPU. So much like in my voxel raycaster, we can use a Y buffer, which stores the highest point for every column on the screen, and only draw if the height is higher than the Y buffer. This turns our measly 0.7 frames per second into an astonishing 4 frames per second. They really don't call me the GOAT for nothing. I also fixed the width of the lines because the aforementioned 2:1 ratio happens to create a space of 1 pixel in between each row. Now that I have a renderer down, what I want to work on next is a simple terrain generator. This here is the result of a simplex noise function. As terrain, it wouldn't really look good, but there's a few tricks to create really interesting features. The first is to layer noise functions at different frequencies and different amplitudes onto one image, ensuring there's large and small features alike. The problem with this approach is that most points end up in the middle range of height, and there's no tall mountains and low valleys, which brings me to my second trick, a sigmoid function. A sigmoid function exaggerates terrain features and at the cost of almost no computational power. I think this final product looks quite nice, and if you want to try it out for yourself, you can find it on GitHub with the link below.